Ooh, bargain finds. Watch band, monkey case. Ooh, glow-in-the-dark glasses. Who wouldn't want these? Buy it now. Remember, my goal for you in this skill was that you would be able to explain network communication using the OSI model. So how did that happen? I mean, glow-in-the-dark goggles, you clicked buy it now. What exactly happened when it's communicating across the network? Can you describe that with the OSI model? Let's talk it through. So here's what happened. We had a computer right here using Firefox, a network-aware application that was already accessing the Amazon website. So over here, we'll just call this Amazon.com. We were looking at a pair of bargain glow-in-the-dark goggles and clicked the Buy It Now button. That became our data. Let's fill that in right here. Now, as soon as we clicked that button, some network communication was generated. Firefox passed it down to the the presentation layer, which is still within the application. You remember these three layers up at the top are all application layers, and they're actually grouped in the TCPIP model, right? So the first thing that happens here is formatting. So it's going to format that buy now click in some way. And this is where my knowledge of the application layer makes me go, it's HTML5, is it JavaScript, is it something that is formatting that buy it now click into actual data that's understood by the server on the other side. Now, one thing I do understand is the encryption. Everything you do on Amazon's website is fully encrypted. So as part of that presentation layer as well, it's going to scramble that buy it now. So if somebody intercepted that along the way, they wouldn't know that you're buying glow-in-the-dark goggles. It then passes it down to the session layer. That work has already been done for us. You remember the session layer within the application. It's going to start a session, maintain the session, log out of the session from the website itself. So that we're already at the website. We're assuming a session has already been established. Now let's get into the network grit. The session layer then passes it down to the transport layer. The application, which happens to be Firefox in this case, dictates that TCP is going to be used for that communication. How do I know that? Because I know that we're using HTTPS right now to communicate with the Amazon web server. Fill in the Amazon.com URL in front of that, which is a TCP-based application. As a matter of fact, it has a well-known port number. Here's a key fact. Port numbers that are 1024 and lower are considered well-known port numbers. That is, they're registered at the authorities out there that govern a lot of our network communication, and no one else should use them. Now, some people do, but no one else should use them besides the well-known application that's been registered for communication. We use the port numbers above 1024, 1025 and above for all of our other applications that are using those ports, right? Now, it just so happens that HTTPS uses SSL, that's Secure Socket Layer, which is registered on a well-known port number 443. That defines the destination TCP port number, 443. Now, I mentioned when I talked about the transport layer communication that we also use a source port number for the Firefox application. Windows, which is what I'm running, automatically generates a dynamic port number, and again, it's going to be above 1024 for Firefox to use. If you're ever curious, open a command prompt on your computer and type in the command netstat. Netstat shows all the open connections that are coming from your computer. Now, it's hanging there because what it's trying to do is, it's called reverse DNS lookups. It's taking IP addresses and converting them to names, which is what you see right here that it's using. And we can see as it's going down this list, each one of these that it's generating. Now, I'm just going to take a wild stab. This is probably one of the connections over to Amazon. The reason I say one of the connections is because when you're looking at a web page, let's just say our Amazon web page right here, you saw, the bargain deals up top, and then we had our picture of our glasses right here that were on there. We had the buy it now button. We had all kinds of different things. The way that websites are built nowadays is each one of these components can and probably are fed from a different server. There's probably an image server that Amazon has that just hosts all the images for their websites. There's probably thousands of image servers that they have based on how big Amazon is. I mean, look at this. You see all of these things? Those are all Amazon. You might say, how do you know, Jeremy? Because I do. Because I've dealt with Amazon quite a bit. EC2 is elastic computing. That's one of Amazon's AWS. It's one of their web services. A represents Amazon. They use different names for all their different servers. So even though I have my one web browser, look at this. These are all connections that Amazon, or I should say my computer, is making to Amazon to feed that one web browser. And look at this. This is me on my computer. Whoa! This is my computer name, by the way, JChar Alien. I'm not really an alien, really. It's a Dell Alien brand computer. But that being said, all of these right here are source port numbers. Let me scroll back up in this list, back to the ones that we're connecting to Amazon. Each one of these is dynamically generated by Windows for the return traffic. So when we created that web instance and went to buy those glasses, as soon as it realized, my computer realized it was connecting to another server, it's like, okay, I'm going to start a new session. Let's just say this is the image server, right? I'm going to start a new session from Firefox. It's going to use source port 33,374. That's going to be what it fills in here as the source port number when it goes to the destination. And now the computer knows when Amazon sends that picture of the glasses back, it's going to put it right in this little square because that is assigned 33,374, and the computer knows that's where the data goes. So back to our story. We click the Buy It Now button. That's our data. Firefox chose to use TCP and generated the source port and filled in the destination port. So when it gets to Amazon server, it knows which server application it should give it to. Now it fills in the source and destination IP address. This is known as the network layer or logical addressing. Now we, as the network designers, will come up with the IP addressing that we're going to use on our network. And in this example, I'll say this is let's go with 192.168.1.0/24. That is the most common network in the world, and it is a mark of shame if you use that in a production network environment, because most of the time people use 192.168.0 and .1 for home networks. And so when I and most network engineers walk into a business network and they see 192.168, most of the time they go, somebody probably didn't know much of what they were doing. Whether that's true or not is totally beside the point, because that's most of the time the default network that's generated by plug-and-play network appliances, right? So let's just say in this case we're using one of those plug-and-play appliances. The computer happens to have the IP address 192.168.1.10. That's going to be filled in here as the source IP address, 192.168.1.10. The destination will be Amazon's website. You saw that when we did the netstat command. I don't remember what those were, so let's just call it 1.1.1.1. That's the destination. Now that data moves down from the network layer and hits the data link layer. At the data link layer, it's going to fill in the MAC address, which is considered the layer 2 address that allows local communication to happen. Yes, we're going to 1.1.1 as our destination, but we need to use this router to get there. This computer will use a process we'll talk about a lot more in other skills called ARP to figure out what MAC address this router has. Now, the MAC address is a 12-character hexadecimal thing, and I'll just call this one ABCD. That's what this one's going to fill in as the destination MAC address. The source MAC address will be itself. We'll call that DCBA. Once it's filled in all of this information, it adds something to the end called the frame check sequence. Other people call this the CRC, the cyclical redundancy check. Essentially, it runs what's known as a hash. It's a big mathematical algorithm, taking all this data, putting it into a nice big blender, and coming up with some answer. That answer is going to be put in as the hash into that frame check sequence, into that CRC. And all that makes sure of is that as that frame is transmitted across the network, it doesn't change. Because if any of this data changes, the answer will be different when it gets to the other side, and it'll discard that frame. And by the way, this is where that term frame comes from. It's because at layer 2, right before this computer sends the data, it sticks stuff on the front, that's the destination and source MAC address, and stuff on the end, so it literally frames that communication between two editions on the front and end of the device. Pretty simple. Now I need to pull out my crocodile voice to follow the frame as it goes across the most dangerous network in the world. That was terrible. So it hits the switch. What is the switch weed? That's a different episode. Read, it's the MAC address, right? So the MAC address is going to say, okay, destination MAC is ABCD. I've learned that because that's the router coming in. And so it goes, okay, I'm going to send it out this port. The router gets it. It goes, oh, that's me. Rips off the destination and the source MAC address, looks at the IP address and goes, oh, that's not me. That's somewhere else in the network. It looks at its routing table and says, how do I get to 1.1.1.1? Its routing table says, well, I'm not 100% sure, but I know the next hop goes right here, which is probably your ISP. ISP being the internet service provider that receives that communication. They look at it and they go, actually, before I even go there, I want to ask you the question, how did that router get it to the ISP? Again, we know that we can't just be like, go packet, go find your home. It has to do something. So once again, it's going to use those MAC addresses. It's going to fill in the source MAC address right here, or layer 2 address, and it's going to put the destination MAC address. It figures out what that is and replaces what it ripped off with the new leg of communication. And by the way, that's going to happen every single router all the way to the destination, which is Amazon.com. And I'm showing 3 here, but there's probably 10, 20 different routers between your network and Amazon's. And every single one of those routers rips off the original source and destination MAC address for that little leg and replaces it with the new one. Right? Pretty amazing when you think about it, how fast our network communication happens all the way there and back. Every single one of those little legs ripping and replacing the source and destination MAC address. So let's fast forward a little bit. It hits the router at Amazon's data center. That router then forwards it up to the switch, and the switch looks at the destination MAC address of the server because these two would have figured that out. It's again a new leg of communication, passes it up to the server, and now the server's like, oh, I am 1.1.1. I'm responding to that. So it removes the source and destination IP address, looks at the port number and says, oh, destination port 443, you're heading right up here to, let's just say, Apache, which is the web server application that's serving these images up. Apache looks at Buy It Now, does whatever that application's been configured to do, subtract money from your bank account, record it in a database, all of the different things that happen up at that application. And that's again, once it's past the transport layer, it's out of our hands and into the application until that application's like, hey, send them a confirmation page saying your glasses are on the way. And the same thing happens all the way in reverse. And now here's what I want you to do. This is not a practical skill typically that you can just say, okay, I'm now going to go configure something or do something based on this knowledge I have of the OSI model. But if you don't do something with it right now, it's going to slowly evaporate, or in my case, quickly evaporate out of your mind. So I want you to do one of two things. One, find a friend. And what I mean is a spouse, a friend, a dog, somebody that's surfing the internet. We have advanced dogs nowadays. Walk up to them as they're clicking a button on their web browser, because that's where everybody lives. It doesn't matter. YouTube, anything. They click something and be like, ooh, I want to explain to you how that just happened right now. And if you have a real friend, they'll be like, oh, I'm curious, tell me. And you'll explain to them exactly what I just explained to you in your own words. And you're probably going to reach, I'm sure, one of the layers, you're going to be like, and then hang on, run back here, watch it. So that's where it picks the port numbers. And they'll be like, what's the port number? And tell them, interact with you, ask questions. This is how you learn. If you don't have a friend or a friend who would be willing to listen to you or a friend that surfs the internet, I'm telling you right now, grab a piece of paper or a paper towel. I literally just ran into the bathroom, no, just for this towel, because I'm like, if you don't have a paper, grab a paper and draw up similar. I mean, think to yourself, just say, do something online and say, okay, I've done that. And then literally draw the OSI model and connections and everything that I just drew on that example for yourself. I'm telling you this because these concepts are solidified in your doing them. And since they're not something you can configure, you're doing is explaining it to somebody or explaining to yourself how this whole thing works. You should now be able to explain how network communication happens through the eyes of the OSI model. I hope this has been informative for you, and I'd like to thank you for viewing.